Lesson 27 BB is a review lesson. We're going to put everything that we've been doing with proportional relationships together. So that was the ratios, the tables, the graphing. We're going to put all of them together in the same problem for you to match them all up to be extra certain that your answer is proportional or not proportional. And we're still finding that constant. Okay, so background knowledge, we found constant using a table. So you would list out all the ratios, y over x. If they're all the same number, it's proportional. And that number is k. So in this case, k equals what? 60. And since this is talking about how tall that bamboo is in such a number of days, that 60 as a unit rate would be what? Good, 60 centimeters per day. Remember, unit rate and constant are the same number. Linear graph, it has to be a straight, perfect line. Fill in the blanks here. A graph that is a line. And the origin is what we call the ordered pair 0, 0 with parentheses. Those parentheses are what makes it an ordered pair. If you don't write them, it looks like just a string of numbers. Okay? So, from yesterday, we learned how to read this graph. Is it proportional or not? What do you think? Yes, it is. How do you know? Grace?
Because it's linear and the line touches the origin.
Good, because it's linear and goes through the origin. So this one is, yes, it's proportional. How about this graph? Yes or no? No. How do you know? Because it doesn't go through the origin. It doesn't matter that it's linear. It doesn't go through the origin, so it's not proportional. How about this graph? No, why? Because it's not linear. Very good. So it doesn't matter that it goes through the origin. If it's not linear, then it's not proportional. All right, number 1 on your notes. We have this table, number of books compared to how much it costs. We're going to label books X, cost Y. And I want to know if this is proportional or not. You're going to do all the different methods. Use that table to graph it. Use that table to list out all the ratios. Use that graph to find k. Use the ratios to find k. Everything should match up. I also want you to start labeling these axes. So since this is x is number of books, that means this is going to be books, number of books, and y is cost. So I'm going to write cost here. Cost in dollars. You go ahead and plot those points. I'll give you rulers. Okay, so this cups of red paint comparing to cups of blue paint. We labeled our axes, and then we plotted the points. Over 3, up 2. Over 12, up 8. Over 15, up 10. Your line should go through the origin, meaning it's proportional. And then I asked you to check the ratios, so that's 2 over 3, 8 over 12, and 10 over 15. They all reduce to what? 2/3, which means k equals 2/3. Ratios are equivalent, so it's proportional. There's one more thing I want you to do. Please label k on your graph. The constant is 2/3, but I also want you to label this point, 1, 2/3. Now obviously 2/3 is really hard to read as a graph, which is why you got that exact number using your ratios. You can just fill in 1, something. That's something you did with ratios. Just write that number in, because it's too hard to read on a graph. Okay? Turn your notes over. Number 3 is yards of dirt compared to how many hours it took to dig it out. I want you to do the same thing. Label X and Y on your graph. Which one's hours, which one's yards? Graph it, check it with ratios, Tell me if there is a K. We labeled ours on the bottom, yours on the side. This is 1, 4, 2, 8, 3, 12, 5, 20, meaning over 5, up 20. Your line should go through the origin, meaning it's proportional. And then I asked you to check with ratios as well. So from the table, y over x, 4 over 1, 8 over 2, which is 4 over 1, 12 over 3, which is 4 over 1, and 20 over 5, which is 4 over 1. Do they all match? Yes, the ratios are equivalent. That is your second reason why this is proportional. What's the constant? K equals 4. K equals 4. And I want you to label that on your graph, please, meaning 1, 4. There is no dot there, so you're going to make it. Oh, there was a dot there, so just label it. Label it. In parentheses, 1, 4. This is your K spot. Okay? K equals 4. This next fill in the blanks, I bet you can do this without my help. Go ahead and write those words. This is old news now. If all ratios from the table are simplified and equivalent, that ratio represents what? Good. Unit rate and what's the same thing? Constant of proportionality. Where do you find constant on a graph? Sean? Good. Where the point 1, K is. 1, K. K is what we use to represent that whole big old long word, constant of proportionality. All right. Number 4. I graphed it for you this time. I want you to find K using only the graph. Practice using that 1, K. What's K?
4.
Good. Over 1 up until I hit the line, and it happens to hit at 4. So you're going to label it 1, 4. In parentheses, please. Label it on your graph. K equals 4. Now, using that graph, there's a bunch of points on there that are really easy to read. I want you to fill out the table using those points. So the first one, obviously, is 1, 4. What's the next one? 2,
12.
8, 3, 12, 4, 20. So I'm reading it by going over until I hit the dot up. Over 1, up 4. Over 2, up 8. So if you used ratios here, you can also see that they all reduce to 4 over 1. And since there's a 1 in the table, I see that 1, 4 here. That's my constant. Okay? Everything coming together? Good. Do number 5. Again, I graphed it for you. Find K just by reading it. What would K be? Over 1, up 6. Please label it 1, 6 in parentheses. That means K equals 6. Use that graph to fill in the table. First one's 1, 6, obviously. Tell me, what's the rest of the values? 2,
12,
3,
18,
4.
24.
Good. Even though 24 was off the graph, you know it's proportional, right? Because it's linear, it goes through the origin. So you can use just the pattern here, and you know the next one's 24. 1, 6 is the constant spot where you find it. K equals 6 is the constant. Number 6 on the next page. Use the graph only to find K. Is there a dot there this time?
No.
Nope. That means you're going to make it. Over 1 until you hit the graph. Over 1, up. What number is that? 3. Good. I'm so glad you didn't say 6. It's not the first dot. It's the over 1 up till the line. So just because there's no dot doesn't mean it's not there. You make that dot. 1, 3. Label it. Right, k equals 3. I already filled in the table for you, so you're just going to check the ratios. Make sure those ratios come out to 3 as well. That table is there for you to check ratios. Do they all reduce to 3? Yes. Now notice on this table, so far all the tables had a 1 constant in it, right? This table starts with 2. Since that's not a 1, you cannot use that as your constant. 6 is not the constant. Just because it's the first dot on your graph, the first values in your table, doesn't mean that's constant. That's just one of the dots. Okay, you need to use the ratios to find 3. Okay, make sense? Just be careful, it's not the first dot. It's go over 1 up until you hit k. K is 3, not 6. All right, number 7, we're going to start off with these word problems now. This car shop, Phillip's car shop, charges $25 per hour to fix a car. I want you to complete the graph and label the axes. So, look at this part. It says he charges $25 per hour. What does that sound like to you? Per hour, per hour, per hour. Unit rate. If that's unit rate, we know that's y over x, right? Y over x would be dollars per hour, according to that little phrase there, $25 per hour. So which one would be the x, which one would be the y that we're used to? One would be x. In our table, cost is c, which is dollars, which is what we're used to as y. So I'm just going to put in parentheses here for my own reference that this is what we usually have as y, and this is what we usually have as x. So our graph, I have to label with t and c because that's what they're telling me to use. Which one is t? X or y? X. So that's the bottom one, right? The x-axis is going to be t, so I'm going to write t there and then label it time. Cost in dollars is our usual y. That's the y-axis. So I'm going to label this one C, and this axis I'm going to write cost. Now you're going to fill in your graph with those dots. Over 1 up 25, over 2 up 50, and so on. So time on the x-axis, cost on the y-axis, and I'm going to put all of my points in. Connect it as straight as you can. Does it look like it's a proportional relationship? Yeah. Yeah, it goes through 0, it's linear. They actually even told us a unit rate, right? $25 per hour. Unit rates only exist if it's proportional. So, is it proportional? Yeah. What's the constant? 25. What's the unit rate?
$25.
Good, it was actually in the problem, right? $25 per hour. Per hour. All right, number 8, same thing. Larry's Auto Shop charges an initial fee of $40 and then $20 per hour. Complete the table, label the axes. So let's label the axes first. Which one is T? That one is our x, so I'm going to put that on my x-axis. T is for time, and C is my y-axis for cost. It's already graphed, so I can fill in my table. First one's at 160, next one's at 80, 300, 4, 125, 140. Is it proportional? Why do you say no? Emilio?
Because if number 3 would be 120 instead of 100 if it was proportional.
No, look at our graph. Why is it not proportional, Sean? Because it doesn't go through the origin. Because he charges an initial fee of 40, meaning you walk into the shop and you get charged a fee. You start at 0.40 instead of 0.0. On your table, if this had a 0, this would be 0.40. We don't want 0.40, we want 0.0. So this is not proportional because there's an initial fee. That initial fee makes your graph start at 0.40 instead of 0.0. Okay? So what is the constant of proportionality?
There is no.
Good. There is no constant. It's not proportional, so there's no constant. It's called a constant of proportionality, after all. Okay? Number 9, almost done. Modesto Pools charges a $4 entry fee and then $2 per hour for to use your pool, their pool. Let's label these axes. Which one's time, which one's cost? Time is X, so I'm going to put T down here for time. Cost is Y, so that's C for cost. The graph is not labeled with numbers because it's just going by ones. If it's not labeled sometimes, that just means it goes by 1. So let's fill in this table. 1 comma 6, 2 comma 8, 3 comma 10, 4 comma 12, and then 5, 14. Is this proportional? No. How come? Yeah? Say it again. It doesn't go through the origin because there is that $4 entry fee. You walk into that pool place and they charge you. So that's 0.4 instead of 0.0. Let's do number 10. Label those axes. Time is on the bottom. Cost is on the side. I gave you the table this time. You're going to graph it. All right, here are my points. Here's my line. Is it proportional?
Yes.
Yes. How do you know?
Because it's both linear and goes to the origin.
Excellent. It's both linear and it goes to the origin. And it's going through the origin because this pool place, when you walk in and you don't swim yet, they don't charge you. So that's 0.0. If there was an initial fee, that means you walk in and you already paid money. So this is proportional. If there was a 0 on your table, it would be $0. So it would be 0.0. What's the constant? What is it? 3. What's the unit rate? $3 per hour. Very good. Any questions? All right. Number 2s. Would you please share what you learned today? Ready? Share.
Okay.